All right, let's talk about a piece of AI tech that is absolutely flying under the radar right now, but really shouldn't be. We're diving into something called Youtu-VL. You know how it is in the world of AI. Things move so fast, it is incredibly easy for some amazing developments to just get lost in the noise. And this is one of them. While all the big names are grabbing the headlines, this model has been quietly making some serious waves. So let's get right to it. What exactly is Youtu-VL? Well, it's a new vision language model, or VLM, from Tencent's Youtu Lab. And it's really starting to challenge how we think about AI seeing and understanding the world. Okay, so if you look at the specs, a few things really jump out. It's built on an existing language model, sure, but check this out. It has only 4 billion parameters. Now, in a time of absolutely gigantic models, this one is designed from the ground up to be lightweight and efficient, without giving up that sharp visual perception. And that efficiency, it comes from a really core innovation in its architecture. And believe me, this is where things start to get pretty interesting. I mean, with so many visual models out there, you have to ask, right? What makes Youtu-VL any different from the rest? Well, the answer is all in how it learns. The secret sauce here is a framework they call VLUS. I know that is a mouthful, but the concept is actually brilliant. It's built to solve a really common problem in AI, where the model pays way more attention to the text you give it than the image itself. And when that happens, it often misses important visual details. So VLUS is all about making the model treat the image with the exact same importance as the text. And the difference is, well, it's fundamental. In a lot of older models, the image is just kind of background context for the text. But with this VLUS system, the image and the text are equal partners. The model doesn't just glance at the picture, it actively works to reconstruct it, to really understand all the dense visual information. And it does it all within a standard architecture. So how does it pull this off? It's basically a simple 3-step process. First, it unifies everything, the image and the text, into a single language of what are called tokens. Just think of these as tiny pieces of data, like words in a sentence. Then it processes both types of tokens together in one decoder. That's the part of the AI that puts the final output together. And finally, it just predicts the next token in a sequence, treating the visual and text information as part of the exact same stream. It's a really elegant solution. Okay, so that all sounds great in theory, but how does it actually perform in the real world? Let's put it to the test with a few examples from the source material. All right, first up, a simple, pretty fundamental test. Can the model accurately read an analog clock? This is a great way to check its basic visual sharpness and its simple reasoning skills. And the prompt we're giving it is super straightforward, just a direct question about what it sees in the image. And boom! The answer is clean, direct, and perfectly correct. It absolutely nails the basics, which is exactly what you want to see. A really solid start. Okay, now for a much tougher challenge. This next test is designed to really push one of the model's biggest claim strengths, identifying all the different objects in a super complex scene. So the prompt is asking the model to basically take inventory of this really busy AI-generated market scene. I mean, there's a lot going on here, tons of small overlapping details. And wow, the level of detail in this response is just incredible. It doesn't just list people, it actually categorizes them as shoppers and vendors. It spots these tiny details like the hard-to-see fish in the stalls or the street lamps that kind of blend into the background. It even found the watermark on the image. This is a perfect example of its fine-grained perception. All right, for the final test, we're going to look at its ability to read text inside an image, a skill known as OCR. But this prompt adds a little layer of reasoning on top of it. So you see, the question isn't just what does the bottle say? It requires the model to read the label and then apply that information to answer a health-related question. And it absolutely passes with flying colors. It correctly reads no sugar on the label, answers the question directly, and then, and this is the really critical part, it adds a responsible disclaimer to consult a doctor. So it's not just seeing, it's actually understanding the context. So after seeing it in action, how does this all stack up? Let's take a step back and break it down with a balanced scorecard. Okay, on the pro side, its object detection is incredibly granular, its spatial reasoning is strong, and it is highly efficient. For the cons? Well, while it handled that OCR test pretty well, there are specialized models that are still better for just that task. And of course, it's jumping into a very, very crowded field. But here's the crucial point. The thing that really defines this model's niche, its efficiency. The source material shows it running with just over 8 gigabytes of VRAM. That's the memory on a graphics card. That is remarkably low, and it makes this powerful tool accessible to people who don't have these massive, high-end GPU setups. So, what's the final takeaway here? Who is this model really for, and why should we be paying attention to it? Youtu-VL really carves out a clear space for itself. It's pretty much perfect for developers and hobbyists who have hardware limits, but still need top-tier object detection. Really, it's for any application where getting those super fine-grained visual details right is the most important thing. And that leaves us with a final thought. We often focus on making AI models bigger and bigger, but maybe the real breakthrough is making them this powerful while also being this small and this accessible. Could this kind of efficiency be the real key to putting advanced AI vision into the hands of everyone? It's definitely something to think about. Thanks for joining this explainer.